corrections from the work I posted yesterday for you. I posted a video on Tuesday running through a couple of the examples, so hopefully we didn't have too much trouble attempting these based around the work that I've been doing there. So just want to run through these very quickly. So I've done, as you can see, part 1 and part 3 from question 1. I picked those two because one is positive, it's got a positive d value, and this one's got a negative d value, so that's why I wanted to show you the difference between the two. So it's asking to find the sum of the first 20 terms. Okay, so I'm going to use this formula, our new formula. We've got our general term and we've got our arithmetic series, or our ghost term here that we want to use. Okay, so we've got our formula, n again being the number term, a being the start point, and n, as I said, being the number of terms. In this case it's 20, as we can see in the question there, and d is the common difference. Okay, so we can see we've got our sequence there, and it starts at 11, it goes up in 11s, and it goes for 20 terms. So I'll just fill all of those values into the formula. Got my n value there, my a value, my n value, my d value. Bit of multiplication and stuff like that, running through, breaking down step by step by step, and you can see all that there, and I've done it bit by bit, and I end up with 2,310 in this case. So that is the sum of the first 20 terms of the sequence. So if I was to add 11 plus 22 plus 33 plus 44 plus 55 and so on all the way up to 20 terms, I would get that value. So for part 3, exactly the same process. Only difference here is that I've got a negative d value because the term is going downwards. We're subtracting 3 each time. So it's going 43, 40, 37 and so on. Okay, so again, I've got my start point, I've got my common difference, and I've got my number of terms. I fill them in where I see them in the formula, and I work all that out, and I get an answer of 290. Now, I want you to look at the difference. As I said, I've written here, look at the totals and compare. 290 is way lower than what we got in the first one. The reason for that is because this value in part 3, the value is going downwards. You can imagine if I count that for another 10 times or another 15 times, I'm going to end up close to 0, or I'm going to end up in a negative value. So that number is going down each time. So 43 plus 40 is 83, and then I add another 37, but the number that I'm adding on is decreasing each time. So hence why this number isn't as high as what we got up here, because the number is increasing every time in part 1. It's going up and up and up. So that's why the two of those are so different in the way they look. Question 3 then, I did parts 2 and parts 4, again for similar reasons that I talked about in question 1. This has got an addition for the d value, and this has got a subtraction for the d value. So I just wanted to put those in. I also wanted to show you these ones because they've got a negative a value at the start. It doesn't have much of a bearing, but you'll notice and you'll see it yourself. So I've got my sequence, I've got my formula, I've got my a, my d, my n values. I'm going to fill them in. So pop them into the formula as we have done here. N value there, a value, n value, d value. Okay, fill it all in and I get 190. So 190 is the sum of these terms, 190. If I add the first 10 of those together, okay, because I asked in the question the first 10 terms, so that's why I've got an n value of 10 in both sections. So I've got 190 here. Now in part 4, I've got negative value, so negative start value, and the negative value is increasing each time. So it's you can see the d is minus 2. Okay, the common difference is minus 2 because I have to subtract 2 each time. So it's becoming a bigger negative number, and we fill them in as we have done. I'm not going to run through it all again, and we end up with a value of minus 170. That's the first negative answer that you've seen. As I've said, I want you to compare again positive versus negative. We can see I've got a positive d value in part 2. I end up with a positive number, I've got a negative d value, I end up with a negative number, because in the sequence in part 4, I'm getting more and more negative, okay? It's becoming more negative each time. So the negative value at the end is getting much, much bigger. Question 6 then. A little bit different here. It's asking how many terms are there in this arithmetic sequence, or series I should say, sorry. It's going 2 to 4 to 6 all the way up to 80, okay? So it's asking that. It's in 2 parts, and then the next bit, it has to find our sum. So this is the bit that we're used to doing in question 1 and question 3. Nice and straightforward, we'll be able to do that, no problem. But I need to know what the term number is. I need to know what my n value is to figure this out. So I go back to my general term formula that we were using a couple of days ago. I've got a, n, and d. I know what a is, the start point is 2. I know what d is, plus 2, because it's going up in 2s each time. And I don't know what the n is, okay? I don't know what the final term would be, but I know that the final term in the series is 80. So what I can do is I can put in the general term formula, and I can put it equal to 80. So I fill in all my values. I've got my a value, my n value, my d value, and I know that it's equal to 80, and I'm going to use this then to solve for n. So you can see I multiply out my brackets, 2 by n, 2 by minus 1, I end up with this. Bring all the numbers to the right hand side, they cancel, so I end up with 2n is equal to 80, showing me that n is equal to 40. So there are 40 terms, and that's what we're saying, okay? Now, I could have done that a different way. I could have just counted, I could have listed out all of the numbers 2, 4, 6, 8, 10, 12, all the way up to 80, and just counted how many there were. But again, if they gave you a number of 1,000 instead of 80, you'd be there a long, long time. So I would strongly suggest going around this route. Also, if we think about what's happening in this series, I've got 2, 4, 6, 8, 10, 12, and so on. You can see that it's multiples of 2. You can see it's going up in 2s. I can think about if I've got a common difference, the thing I would mention is how many 2's go into 80. How many times can I put 2 in a list up to 80? And it's 40 times, because 80 over 2 is 40. So that's how many terms there are in the series. But as I said, going down this route is definitely most beneficial, so I would suggest doing so. Then I use that 40 value and I pop it in to my sum formula like we were doing in question 1, question 3, and nothing different there. I've got my a, I've got my n now, I've got my d value, I fill them all in, n goes up there as well, so a, n, d, pop it all in, and I get my answer. Alright, nice and straightforward. No unit on these as well, we're just talking about numbers, so we're not talking about money, or we're not talking about meters or anything like that. It's just a number to finish off. Finally, question 7. Very, very similar to what we were doing in question 1, question 3. It's just this little bit at the very end is a bit different, okay? So it's asking you, we've given you a series. It's asking you to get the sum of the first 10, the first 20, and then it says hence, because using, so when we talk about hence, okay? Hence generally means that we have to use info that we've gotten in the previous parts. So we got to use something that we've learned, or use something that we've worked out from previously. Use something from the previous questions, okay? From the previous parts, I would say. So I'm looking at part 1 and part 2. Once I see hence, I'm saying, right, there's something in part 1 and part 2 that I need to use here to figure out what's going on in part 3. So I've got 1 plus 7 plus 13 plus 19. That's my series. Got my start value, got my common difference, got my first 10 terms for part 1. So I fill them all into that formula, nice and straightforward, and I get my 280. Again, you can pause it, you can look at that carefully to see the working step by step, but nothing too strenuous based on what we've done in question 1 and 3. It's exactly the same. So that's part 1 done. Part 2, exactly the same, but I'm using an n value of 20 instead of an n value of 10. So I fill it all in the same way, and I end up with this. Okay, so I've got my 2 values. This is for the s of 10, and this is for the S of 20. Now what the question asks in part 3, find the sum of the second 10 terms. So you can imagine the first 10 terms are 1 plus 7 plus 13 plus 19 plus whatever up to the 10th one. If I add all those together, it would give me 280. Once I get to term 11, term 12, term 13, up to term 20, that's how much I want. So I know all of the 20 added together are equal to this, and I know all of the first 10 are equal to this. So all I got to do is subtract them. If I do the bigger one, 1160 minus the 280, it will give me the value of from term 11 up to term 20, if you get me. Alright, so that's all there is to it. I'll see what you guys have got to do today then, and we've got to run through a couple more, so I'll post that up with this correction video. Thank you very much.